Newton's laws of motion. Before I tell you more, let me tell you why it's called Newton. Newton who? No, not him. No, him. Sir Isaac Newton. What do you know about him? Pause the video and write down what you know. He is known as father of modern science, master of gravity, the first physicist, science revolutionist, the greatest scientist, and for many, many more. Let's go back in history to where it all began. Sir Isaac Newton was born a couple of months prematurely in England on the 4th of January 1643. There was no hope for him to survive. His father, Isaac Newton, was a farmer who died 3 months before his son was born. That same year Newton was born, his role model, Galileo Galilei, died. Already as a child, Newton observed his surroundings and loved constructing models, like a small mill that grounded flour which was powered by a mouse running on a wheel. His mother remarried when he was 3 years old, and he was then sent off to live with his grandmother till she had passed away. Newton was 12 years old. From the age of 12 to 17, he attended the King's School where no science or mathematics were taught. His uncle was the headmaster there. At the age of 17, his mother thought it was a great idea and took him out of school and wanted him to become a farmer. Luckily, Newton was so bad at farming, and through the influence of his uncle, his mother allowed him to finish his education and let him go to college. Newton was 18 when he started to go to University of Cambridge Trinity College. He first studied law, then mathematics and natural philosophy, which is today called physics. He learned about Galileo's principle of motion, heaviness. After his 3 years of college, he won a 4-year scholarship. At the age of 22, he began his scholarship in mathematics. That is when he discovered the general binomial theorem and was awarded with a Bachelor of Arts degree that same year. The bubonic plague broke out that year and Cambridge was forced to close. Newton returned home, and that is when he discovered gravity. After watching an apple fall from a tree and land on the ground, at the same time the moon was to be seen in the sky. That is when he invented the theory of law of gravity and the 3 laws of motion. He was only 23 years old. He said that it was the prime of his age for inventions. What is he known for? Newton returned to Cambridge at the age of 24 when he was almost 26 years old. He received his degree in Masters of Arts. At the age of 26, Newton was chosen to replace his mathematics professor. In the year 1687, his book, The Principia, was published, in which he revealed his laws of motion and gravitation. Only few people understood his book. Where he walked past some students one day, one student said to another, "There goes a man who has written a book that neither he nor anybody else understands." Newton was a largely self-taught in mathematics and physics and had many achievements and discoveries in his lifetime, like the calculus, optics, and the behavior of light. Sir Isaac Newton died at the age of 84 and was buried in the Westminster Abbey. So enough about history. Let's talk about physics. The laws of motion. What are they? According to Wikipedia, The three basic laws of classical mechanics that describe the relationship between the motion of an object and the forces acting on it. Have you heard of the three laws? Pause this video to answer. The first law is called inertia. An object at rest will remain at rest, and an object in motion will stay in motion unless acted upon by an unbalanced outside force. This means the applied unbalanced force does not have to come from humans, but can be from a combination of sources. Example, a table will not move by itself even if you command it to. No, nothing. It will only move if you push or pull it. What is inertia? It is the tendency of a body or an object to resist a change in motion or rest. What does this mean? For example, when a vehicle stops, passengers tend to fall forward before coming to a complete stop. In the same way, the passengers will fall backwards when the vehicle begins to move. More mass an object has, the more inertia there is. This is a good example of inertia. Pull on the beads and they will start moving. An object that is moving will continue moving at the same speed as straight line unless outside force is strong enough to speed it up, slow it down, stop, or cause it to change directions. Now look at this in slow motion. Amazing, is it not? Let's look at an experiment. I call it coin paper cup. You need for this experiment a coin, obviously, a cup, preferably a glass, and a paper that is thick enough, or a card, and should be as wide as the glass. When the paper is pulled on gently, the coin does not move. When enough force acting on the paper, like the flicking of the paper, the coin, what happens? Will fall down into the glass. What happened? Gravity and inertia combined to neatly drop the coin in the glass. When you flick the paper out from under the coin, you allow gravity and outside force to act on it and drop it into the glass. The bottom of the glass stops the coin from falling. Let's look at this in slow motion. That's kind of cool, isn't it? What is force? Influences an object to change its motion. An object at rest will start to move if influenced through a force. Force does not keep objects moving. Push and pull, gravity, magnetism, acceleration, and friction. A force has a direction as well as a magnitude. Such quantities are called vectors. Here's an example. Pushing a ball. Here are two balls, a tennis ball and a massage ball. There are balanced forces and there are unbalanced forces. Balanced forces are equal, will cause no change in the speed of an object when two or more forces acting on an object are equal in all directions. For example, like here, tug of war. Unbalanced forces or unbalanced force are not equal and they cause the motion of an object to change when two or more unequal forces act on an object. Like here, the example, a seesaw. What is friction? A force that can prevent through resistance two surfaces that touch each other from slipping or sliding. There are four types of friction: sliding, fluid, static, and rolling. Sliding friction is where two surfaces slide past another. For example, skiing. Fluid friction, water and air, the force resistance acts in the opposite direction to the motion, like sailing. Static friction, two surfaces are not moving past each other like a car parked on a hill. Rolling friction is friction between a rolling object and the surface it's rolling on, like, example, a skateboard. The absence of friction, the object will continue in motion with the same speed and direction. Let's look at an experiment. It's called a floating rice, but since I don't have rice, I use millets. Works the same. And what you need for this experiment is a bottle, I prefer a plastic one, 500 grams millets, a pencil, and a funnel to make sure that all the millets end up in the bottle. So what I did, I took the bottle and the funnel, and I took the millets and poured them in the bottle. Fill the bottle almost completely with millets. And then take the pencil, with the not pointy end, of course, and jab the millets in the bottle several times, forcing the millets down into the bottle, making sure that there's no room, no air between the millets. Do this a couple times. Till you think it's good enough. And then take the funnel and repeat filling the bottle with the millets. And then you take the pencil and repeat jabbing the millets in the bottle. Till the pencil does not move anymore once you stuck it in. Keep jabbing and jabbing. The jabbing helps the millets fill in that there's no space in between. And then when it's full and there's no room in between, that's why I have to put a little more. Just a little, not too much. And now carefully, they all fly out again. Carefully. Press it down, jab it. And ta-da! The floating millets. Another example, remember the two balls from before being pushed? Why does the massage ball come to a stop? Press the pause button to take a moment to think. And do you know the answer? Because of the spikes on the massage ball that causes the friction. Now you know about the first law of motion. Go do these exercises. The second law is called acceleration. Force is equal to the change in momentum per change in time. What does that mean? The force applied upon the object and the mass, weight, of the object determines its acceleration. An object speeds up due to the force acting on it. Forces are imbalanced. What is acceleration? The rate at which the velocity of a body changes with time. Acceleration depends on the net force and weight. More net force creates more acceleration for a given mass. More mass means less acceleration from a given force. Let's look at some examples. Example here, two piles of books. One pile weighs 700 grams and the other weighs 2 kilograms. Apply the same force to push them, and which one accelerates more? Well, of course, the one with 700 grams. Let's look at the example in another perspective. Same pile of books, the same force, just separately. What do you notice? Of course, the pile with 700 grams accelerates faster. Another example are two of these balls, different in weight, a soccer ball and a cloth ball. They both are the same size. What happened? Why is the heavy one faster? Pause the video to answer the question. The answer is because more force is being acted on the ball. Example, heavier mass rolling downhill. Let's look at this. The heavier ball is the soccer ball. It rolls faster downhill. Objects that are heavier roll downhill faster because of the mass. It takes more force to move an object with more mass. It takes an object with more mass and needs more force to move it. That means an object with more mass needs more force. And the force to stop it need more force to stop the object as well. The second law of motion is known for this formula. F is equal to m times a. F is for force, m is for mass, a is for acceleration. Force is N, which is Newton, mass is the kilograms, acceleration is the meter per second squared. And the other two, this A is equal to F divided by M, is just another way of putting it, just like M is equal to F divided by A. It's all the same. Let's look at an experiment. The balloon rocket, I call it. What do you need for this experiment? Well, obviously, of course, a balloon, a straw, I use tape, and a string, which you need to put the straw through, blow the balloon to the fullest and see what happens. Watch. Do you notice something? What do you notice? Pause the video and think about it. The acceleration is not really fast. Now, blow the balloon to half and see what happens. Have you noticed something? Pause again the video to think what happened. Have you noticed? The acceleration is faster. Another example. I have here two exact same bags. They weigh the same, they're the exact same. I'm going to fill one bag with 3 full, of course, soya drink packages. 1, 2, showing you it's full, it's heavy, and 3. Now I'm going to take the other bag and I'm going to leave it empty. What happens? The bag that is lighter doesn't need that much force. The heavier one has more mass, which needs more force. Now you know about the second law of motion. Go do this exercise. The third law is called action and reaction. For every action, there is an equal and opposite reaction. What does that mean? For every force acting on an object, that object exerts an equal force in the opposite direction of the first force. Forces are balanced. It wants to balance itself. When all the forces that act upon an object, it is to be said it has the state of equilibrium. Here's an example. A chair. When you sit in a chair, your body is constantly pushing on the chair with a downward force. The chair is pushing up back with an upward force. Otherwise, the chair would collapse. Another example, a punching bag. Punch 10 pounds of force, you will receive 10 pounds of force back on your fists. This is the formula for the third law of motion. Object 1 acts on object 2. Object 2 reacts back onto object 1. Here's an experiment. This is an example how rockets launch. For this experiment, you need baking soda, vinegar, a film canister or a film container, what used to be a vitamin canister, and a spoon. What is important in this experiment is that it has to be a 1-to-1 baking soda and vinegar, because if it's 1-to-1, then it works on each other. Otherwise, nothing will happen. Now I gotta shake it. No, not enough shaking. More shaking, more shaking, more shaking, and let's see what happens. Did you see that? What happened? Think about that. I'm going to show you what happens if I turn the container around. Think about what happened last video, and let's take a look at this video. Now it's turned around. Now, count down. 5, 4, 3, 2, 1. The rocket launched. You see that? Amazing. This is Action, reaction. Another amazing experiment, but attention only under parental guidance. Do not do this alone, especially when you're underage. What you need for this experiment: a needle, a candle, a sharp object to cut off both sides of the candle, matches or a lighter, 2 glasses, and, very important, a tray. I ended up using 2 needles because I didn't place it properly, the needle, the first needle. Normally you need 1 needle. So you can see what happens. This is before I lit the candle. And now I lit the candle. Watch what it does. What happens? What happened? It was trying to balance itself out, and it did. Isn't that amazing? Do that candle experiment part 2. The same candle. I took the needle out. I just wanted to see what happened if I used that 1 needle. Attention, again, do not do this alone. Wow, it just keeps spinning like a Ferris wheel. So let's see what happens when I light it. What is it doing? Pause the video to answer. Physics says that the forces are considered to be balanced if the rightward force are balanced by the leftward forces, and the upward forces are balanced by the downward forces. And this is exactly what is happening and what happened. It balanced itself completely. Now you know about the third law of motion. Go do this exercise. Now you know all the 3 laws. Use Newton's 3 laws of motion to explain the outcome of climate change. Thank you for watching.